In case of a mirror, we used to call it as what? Tell me now here. Pole we used to call. And here we used to call it as a optic center. Here we used to call it as simply optic center we'll call. And if the light ray which is passing through the optic center, the light ray doesn't get any deviation. We have this light ray. If the light ray passes through the optic center, the light ray doesn't get any deviation. So this simply straight away will go like this. We have taken the light ray, doesn't get any deviation. And this point is called as optic center. So simply we can treat as the midpoint of the lens, we can call it as an optic center. Optic center, which will denote with a letter of O. So at that location, the light ray doesn't get any deviation. So optic center can lies inside on the surface or outside depending upon the radius of curvature. Optic center, it may be lies inside, it may be lies outside on the surface also. Right. Yeah. Principal axis we know now. The line which passing through the optic center at the center of curvatures. Now here, this is the optic center. So here in this case, we have two radius, that's the two centers we have. So this is the optic center here, this radius. Now you tell me now this is R1 and this is R2, right? Now you tell me now this is the radius of which one? R1 radius or R2 radius? This one. Yes, see this thing here. So if we observe carefully, this R1 radius, this is like this now, this direction. So for this one, center will lies where? Right side or left side? R1 ka. So this R1 ka center will lies right side. This is the center C1. And R2, this is curved here, this direction na. This is the center for C2. Okay. Right, this line which will be called as the principal axis. Now, what is the R1 means what? The distance from here to here. This distance, this distance is called as a R1. R2 is what will be now center C2 to this surface. This distance is the radius of curvature of second one, R2. Right. Now this lens will have a two surfaces as well as two focal points, isn't it? This surface will have one focus, this will have another focus. Okay. So if I call the focus of this one here, this one, this is the focus of the first one, now we can say F1. This is the focus of the second surface, that is F2. Focus will lies toward the center, isn't it? Focus will lies toward the center. If we have the surface like this, center lies here somewhere. Yes, this is the center, and focus will lie somewhere here. Okay. It has a two focus and two centers. Yes. And if the medium in the left and right both are same medium is there, then the principal focus distance is equal to the second principal focus. First principal focus distance, F1 and F2 both values are equal. When, so here the medium, whatever the medium lies now here, if this medium and mu1 and mu2 if I call, if these mediums are equal, if the mu1, mu2 both are equal, the focal length F1, F2 both are same. If it is not equal, focal lengths are different. Okay. Yes, so that's why, but here this focal length, one will be a direction positive, other one direction is negative. That's why we can say mod F1 equal to mod F2 will write. Focal length magnitudes are same. Next. Sign convention. The sign convention which is same as the like we what we have seen a mirror's case. So earlier we used to measure all the distances from where we'll measure from the pole. Here we'll measure from the optic center. That is only the difference. Remaining sign convention same as a earlier what we have seen. So first step what we need to do here, we need to take a light ray should be fall from the object to the lens, and that will be taken as a positive, that will be taken as a positive, and all the distances we have to measure from where optic center, like a pole here it is optic center, and the distances along the direction of incident ray, along the direction of incident ray are positive, opposite to incident ray negative, and the heights above the principal axis is positive, below the principal axis is negative. And the focal length, like earlier mirrors also same thing, lenses also same thing. And focal length for the convex lens is positive, for concave lens is negative. Right.